Yep. Good evening, everyone. Switch on your cams. Let's start off. Yep. Cams on, everyone. So last thing we are doing, right, is the spherical capacitors. Hope everyone went through the notes. So let's see some questions on this. So remember last time I showed you this thing. If you take a capacitor, if you take a shell and you put a charge Q, it's like a capacitor with the R2 as infinity. The energy is Q square by 2C, which is nothing but the self energy. I could have solved the same question in another way. Let's say we have a hollow conducting shell of radius R. The charge Q. Now remember, we said the field is nothing but another form of energy. So in advance, or even this thing, they can ask a question like this. Find energy stored from x is equal to r to x is equal to 2r. X is the distance from the center. So you're saying electric field is nothing but a different form of energy. So how much energy is stored from r to 2r? Which formula to use? Anyone can tell me which formula to use? Do you remember this?
E is equal to A naught by R square, B square.
No. This one, remember energy density, energy per unit volume, half epsilon E square. How to do this thing? Try. I'll give 2 minutes. This is a pretty good question, huh? You know the total energy stored is kq square root 2r. What if I want energy only from r to 2r? Find the energy stored from r to 2r. Try for 2 minutes, then I'll show you. Everyone should definitely revise your Gauss law notes once. And I hope everyone started solving Gauss law. I'll be sending the new test schedule. This week there is no test. How do you do this? Half epsilon E square. How do we apply that? So I'll show you one, then you try one more like this. So we got a shell here at a distance x from center. I'll take a thin shell. Remember the formula is energy per unit volume. So I need to take a thin volume here of thickness dx. So energy stored is half epsilon E square into volume. So the small energy stored here is half epsilon. What is the electric field outside the shell? Anyone remembers the formula?
K cube R square.
K cube R square. So K Q by x square ka whole square. Volume is how much? 4 pi x square into dx. This is the volume of the thin shell. So you took a shell of radius x and thickness dx. So you want to find the total energy stored. So if you find the energy stored, you want to find from R to 2R, right? Just let me show you from R to infinity what you get. I didn't ask you from R to infinity, but let's see. This is k square, q square, 4 pi, that will be dx by x square. This turns out to be half epsilon, k square is nothing but 4 square, pi square, epsilon square, q square, and 4 pi dx by x square is minus 1 by x. Limits will go from R to infinity. 1 4 pi epsilon, 4 pi epsilon will cancel. That will become kq square by 2r. Isn't this the self energy? Isn't that the self energy? That's the total energy stored from R to infinity. So when you say the self energy of a shell is kq square 2r, where is that energy stored? The energy is not on the shell, the energy is not inside the shell. The energy is spread from R to infinity in the form of electric field lines. So in our question, you want the energy from R to 2r, right? Just put the limits. Half epsilon 4 square, pi square, r square, q square, dx by x square. Limits will be from R to 2R. If you solve this, you end up with kq square by 4R. You can simplify that. That means out of the total energy, half of the energy is there from R to 2R only. From 2R to infinity, the remaining half of the energy is there. So if this comes in an advanced like exam, you know how they'll ask you? Find the ratio of energy stored from R to 2R and 2R to infinity. 1 is to 1.
Sir, then if we find for 2R, then R, then subtracted, we also get the same.
Same thing. Please check the steps what I did here. Let me give you one more like this. All clear with this? So we are using the formula of energy density of epsilon E square. So this is how you can find energy also. So be careful. This is one different model. All got the clear? All got the concept? Reena, clear? Nishita, Nanya? Ritam, cams on? Anamai, Gauri, got this? Great. Now you guys try this thing. Uniformly charged sphere. Find the ratio of energy stored inside and outside. Let's set this thing. How do you do this? There are two ways to do this. One is pure integration and there is another shorter way.
So then,
But first, let's try to integrate.
first finding from 0 to R, then R to infinity. No?
बस वही करना है. Find the energy from 0 to R and R to infinity. I hope everyone remembers what is the field inside the solid sphere?
KQX by R cube.
KQX by R cube. Everyone, don't forget your basic formulas. Mug up. Field inside a solid sphere, potential inside a solid sphere. Don't forget them. Small things. Trust me, huh? Mains mein they're asking literally direct kind of questions. Meaning this year there is one question, charge q is there, find the potential at point P. That's a question, KQ by R. There are asking out of 25, there will be at least 8 to 10 dumb questions. Just because you didn't revise the formulas, you don't remember the formulas, you'll mess up them. वापस बोल रहा हूँ 100 में scoring 60, 70 is not difficult in physics. If you can manage another 40 marks in maths and 50 marks in chemistry, that will put you in, almost the top 98 percentile. So I do understand there's a lot of things to do. It's okay. You can't do all 100, but do at least 60, 70%. So don't stop working. Keep working. I know there's a lot of things. It's exhausting, but do as much as you can. You never know what can happen till the last day. Happened last year. There is a girl who got 196 in bits. She thought she'll get nothing. She joined in a local college Mumbai. I think I told you. She got into BITS Goa Chemical. 5th round या 6th round में आ गया था उसको. How do you do this? Let's see. First thing, the field, right? K, Q, X by R cube for X less than equal to R. Now, if you forgot this formula, no, that is bad. I'm not asking you to do big problems, but basics you can't forget. X greater than equal to R. This much you should know. So for inside, integral R epsilon K Q X by R cube का whole square into volume is 4 pi X square dx. Limits will go from 0 to R.
Sir, what is to R square?
R square कहाँ से आएगा God? This will be R epsilon. Outside field is K Q by X square whole square 4 pi X square dx. This will go from R to infinity. So if you look at here, all these are constants. Half epsilon K Q 4 pi half epsilon K Q 4 pi. All this is constant. So then this thing turns out to be 1 by R cube integral x square x power 4 dx from 0 to R by integral 1 by x square dx 0 to R to infinity. This would be r power 5 by 5, r power 6 here. R power 5 by 5, 1 by r power 6, and this is minus 1 by x. 1 by infinity is 0, so 1 by r. This is 1:5. Yeah. Please check. There's nothing, just integration there. Any doubts on this? Now, how to do this in another way, an alternate way? If you take a solid charged sphere and if you take a hollow sphere, aren't the field lines outside same? The field outside is how much? E outside is kq by x square. Same for both, isn't it? That means for a solid sphere, energy outside will be same as kq square by 2r, which is same as a hollow sphere, isn't it? As long as the field is same, isn't the energy same? And for a hollow sphere, inside is 0. That means all the energy that is there outside, this fields and this field are identical. Same as hollow sphere. And we know the total energy of a solid sphere anyone remembers total energy of solid sphere ka formula? Self energy of solid sphere? Anyone?
3kq by
Perfect. 3kq square by 5r. So from here, what is inside then? Inside will be nothing but total minus outside. Which is kq square by 2r minus 3kq square by reverse 3kq square by 5r minus kq square by 2r. This is nothing but kq square by 10r. हो गया ना? What is inside and outside का ratio? So inside by outside will be 1 by 10 by 1 by 2, 1:5. Are you getting it? You can completely avoid integration with this. Please check how I did this thing. Because the field outside is same. Hollow sphere or solid sphere, it doesn't matter. The energy outside should remain same. It's a pretty interesting idea. Like, as long as you keep the field line same, it doesn't matter. The energy will remain same. You could have skipped integration, but if this thing doesn't click, integration is always there. Please have a look at this. So these are some little, higher level problems in case of spherical capacitors. Let me show you. There's one more. Any doubts on this, please ask. All clear? Next one. Can I turn the page? Ritam, got this? Hasni, got this? Kavya? Kavish? Geet? Clear. Next one. This we did in Gauss-Law. Let's say we have two shells like this. R and 2R. Let's say this thing has charge Q and this thing has charge 3Q. In between them, there is a switch. And you close the switch. So find the energy of the system before and after closing the switch? Or simply they'll ask you find heat produced, advanced method, which is nothing but initial energy minus final energy. Find heat produced when switch is closed. So first find the charge distributions when switch is closed and switch is open, and find the energy.
Q minus Q4.
Try. I hope you guys remember these questions. This thing we did in Gauss law mein. Remember this question? We added with 2Q minus Q. Idea was the same. I just changed the numbers here. There we couldn't find heat produced because we are missing something. Now you can find here. So let's see what is that. But for now, first find the charges before and after closing the switch. You do that. The second part we will see. Find the charge distribution before and after closing the switch. We'll be having a class tomorrow at 9 o'clock. Sunday there'll be no class. So chill out. Because I think if we take a class on Sunday, the chapter will get over quite fast. You guys won't have time to solve everything. You guys need some time to finish off your backlog also. But next Saturday, we'll wrap up the chapter capacitors. So you'll have some time. So finish off your backlog. Whatever you have, try to finish your backlog by next Wednesday. Next Wednesday, you have to start capacitors. Some of you are dragging a lot. So please, bump up your speed a bit. Start solving HCV. Time permits, you can do my booklet level 1, level 2. That will actually give you more practice. Or you can do your classes, the booklet, anything. Did you get the charge distributions, everyone? We'll be starting with circuits today after this. So these are some main problems. Capacitors, generally, whatever we are doing now, all these are the most ignored ones. What is the charge distribution here? First one, see. Q and 3Q now. So this is Q. This will be opposite minus Q. This is 4Q. Agreed? Can someone tell me how many capacitors are there here?
In between there is one.
There are two capacitors here, C1 and C2. There is one capacitor from here to infinity. Remember, don't forget this. So this is a capacitor between R2R and infinity. This is a capacitor. So basically, whenever you say capacitor, capacitor is not the plates. The space between the plates is a capacitor. The space where you store electric field is a capacitor. Are you getting it? Plates are not the capacitor. The region between them is a capacitor. So C1 is a capacitor. Between R and 2R. And I hope you remember the formula. C1 will be 4 pi epsilon R1, R2, R2 minus R1. 8 pi epsilon R. C2 will be 4 pi epsilon radius. Both are equal, luckily. So what is the energy stored? Energy stored of a capacitor is Q square by 2C1. And what is the charge outside? 4Q whole square by 2C2. You can just treat them like regular capacitors and find the energy of the system. This itself is a question in mains. Find the energy of the system. Please check the steps. This we couldn't do in Gauss law because Gauss law mein finding energy was a big mess. But here you can simply use capacitor and finish it off. Namme, you got that right. Now the second part of the question abhi tak hua nahi. Now if I close the switch, now find the charge distribution and find the energy. Try, I'll give you a minute. Charge is Q and 3Q. If you close the switch, now find the new charge distribution. Find the charge distribution. That we have done.
Thus, can you show the question?
If you close the switch, what the charge distribution? Do you guys remember I told you a shortcut to find the charge? Anyone remembers that? You know what was the shortcut I said? If you close the switch, if there is a charge here, there will be field lines from here to here. If there are field lines, means here and here potential is different. But because you connected with a wire, potential should be same. That means this charge is zero na inside. Do you guys remember that?
Yeah, inside 0 and outside is 4Q.
Where did we write that? Here. If Q is not 0, there will be a field between R and 2R and potential should change, but VA is equal to VB. Therefore, Q is 0. I hope you remember that logic there. That was a much faster way of doing rather than actually finding potential and everything. But okay, I'll show you with the potential. But that won't be valid if you ground the inertial. That be careful. Every time it is not true. If you're grounding something, it won't be true. So let the charge be Q. This will be minus Q, and the total charge is 4Q. Let this point be A, and let this point be B. This is R, and this is 2R. So potential at A is equal to potential at B. Now, when you say potential, it is due to everyone. Remember, there are three distributions here. So K, Q by R, K 4Q minus small q by 2R, because point A is inside the shell. For point B, KQ by 2R, K 4Q minus Q by 2R. This and this will cancel. We get KQ by 2R is 0, implies Q is equal to 0. So simply, this is your charge distribution. 0, 0, and this is 4Q. Now you tell me, so this capacitor is C1, this capacitor is C2. What is the energy stored? 0, because there's no charge on C1 capacitor. 4Q whole square by 2C2. Did you observe one thing here? The moment you close the switch, what happened? Did anything change outside? Only the field between the plates vanished, na? This charge vanished, isn't it? So only the energy stored in the C1 capacitor became heat. Does that make sense? When you close the switch, outside nothing happened. Only the field between the plates vanished. That means you can simply say heat produced is final minus initial. E initial minus E final. And you can clearly see only the field between the plates vanished. So here field is there. And between them, E became 0. So the heat produced will be Q square by 2C1. check. This will be a proper advanced question. Mostly they can ask you these kind of things in matrix matching. If I ground something, if I earth something, like if I connect two shells, find the heat produced. So these are Gauss law plus capacitor ka combination questions. Do have a look at this. Ask me if you're confused. Clear? Next thing. Can I turn the page? So that's about spherical capacitors. The third one, cylindrical capacitors. This is the direct question in JEE in bits. Again, the derivation is not that important. So if you have, in real life, if you see now, most of the capacitors are actually cylindrical. These are more easy to construct. No one actually uses parallel plate capacitor and spherical capacitors in real life. Unfortunately, we study them more. So, two coaxial cylinders. And here the battery is connected between the inner and the outer shell. So this becomes a positive plate inside, and this becomes a negative plate. So the field is radial between them. So this capacitance is given by 2 pi epsilon by ln R2 by R1 into length L. And field between them is given by, I hope you remember the formula, field due to an infinite 2k lambda by small r, where small r lies between R2 by R1. Lambda is nothing but Q by L. There's a field between the plates. So cylindrical capacitor, we don't have much, only this much only we have. So these are the three main things. Parallel plate capacitor, we have the maximum. Spherical capacitor, we have especially that self-energy part and that Gauss-Law equations. Cylindrical capacitor, just a formula.
So this capacitance formula we have to remember, or
Yeah, you need to mark it up.
Okay.
Direct question results aayega. This is all what we did till now is one part of the capacitors. Now the second part is circuits. So this what we are going to do now. This is the exact same thing, which you have something similar, seen in heat transfer. We are going to see this in current electricity. But you're going to do in more detail. Clear? Next one. Derivation is not important, right? You just assume a charge Q there, V plus minus V minus integral E dot dr. So V is equal to minus field will be 2k lambda by r into dr. Integrate कर लें, आ जाएगा यहाँ से.
Okay.
Next thing, combination of capacitors. First thing, series. So you say two capacitor series if they have same charge and they're in the same branch. So if you put two capacitors like this, now listen here, there's something important here. Whenever say charge Q is flowing through this thing, whichever plate it touches, right, we will take that as a positive plate. Now, because this is plus Q, this will induce a minus Q. Because a charge Q is induced, the plus Q will flow again here. This will become a positive plate. This will become again a negative plate. Again, this charge Q flows here. What is the meaning of this? The charge literally never goes from this plate to this plate. Are you getting it? But it gives you an illusion. See what is happening. When you get a plus here, what will happen? It will induce minus. Where are you getting this charge from? From this plate, no? The charges are being induced. You know how it is? Did you ever see a relay race? There are four people here. This person runs here, gives that baton here, and this person runs here, and this person runs here, and this person runs here. In reality, this person is not going here, no? But it gives you an illusion the same person is going forward. The charge will never cross this empty space in the middle. Your charge cannot jump from here to here. But the whole circuit will behave as if the same charge Q is flowing through the wire, no? Are you getting the point what I'm saying? When you say a charge Q is flowing through a capacitor, what it means is it is inducing charge. The charge is never flowing actually. So that is one thing we will write. So charge is induced in the opposite plate which gives an impression, which makes us feel as if the charge is flowing through the wire. As the charge is flowing to capacitor. Whereas in reality, charge will never jump across the plates. There's an empty space between the plates. So be careful with this thing. When someone says charge Q is flowing through the capacitor, it doesn't mean the Q is literally going from one plate to another plate. It is being induced, so it gives you feeling as if the charge actually went to the other place. Charge never jumps across the plates. I hope that is making sense. Now in this thing, if you take this as V1 and V2, V1 and V2 are potential differences across the capacitor. So we want to replace this with one single capacitor, C equivalent. So the voltage across this will be V is equal to V1 plus V2, and I know Q is equal to CV. So this is Q by C equivalent is Q by C1 plus Q by C2. This is the formula, reverse of resistors, people, just like springs. So when the capacitors are in series, 1 by C equivalent is 1 by C1 plus 1 by C2. So be little careful with that. Resistors and capacitors will be in reverse here. And the potential difference V1 by V2 will be in the ratio of C2 by C1. The potential will divide in the ratio of opposite capacitances. Q is same. You can note down that. All clear with this? Next thing, parallel capacitors. When do you say parallel? They should have same potential difference and they should be across the same nodes. What do you mean by same nodes? The point where two branches meet is called a node. So this point is a node. The point where two branches meet. What is a branch? The thing between two nodes is called a branch. The definition is circular definition. Point where two branches meet. Meaning between two nodes, what you have is called a branch. Na? What is a node? Point where two branches meet. You can't explain anything better than that. Basically that. Okay. So how does a parallel thing look like? Capacitor. Capacitor. So if you have a charge Q flowing here, Q1, Q2, C1, C2, you want to replace it with one capacitor, C equivalent. So in this case, charge Q will be Q1 plus Q2. This will be C equivalent into V will be C1V plus C2V. Potential difference is same. So C equivalent will be C1 plus C2. The charge flowing Q1 will be C1V, Q2 will be C2V. So Q1 by Q2 will be C1 by C2. The charge will divide in the ratio of capacitances. Now, frankly speaking, no, there's no need to remember this. If you remember, potential is same, and you know formula Q is equal to CV. If V is same, Q is proportional to C, na? And in series, make Q is equal to CV. Series, what is same? Q is same, na? So V is proportional to 1 by C. Are you getting it? That is a better way of remembering than actually trying to mug up. Don't try to mug up. Q is equal to CV. In series, Q is same, so V is proportional to 1 by C. In parallel, V is same, so Q is proportional to C. Clear? That would be a better way to remember. Check this out. Here. Next thing. Wheatstone bridge. It's the same old Wheatstone bridge we have done multiple times. Remember where all we did this thing? First time where did we do? Heat transfer.
Heat
Then where did we
transfer.
do?
Fluid mechanics.
Poiseuille's equation, fluid mechanics. याद है? Viscosity में गया था. So what this thing says is, if you have capacitor, and if you have a capacitor like this, C1, C2, C3, C4 and C5. If C1 by C2 becomes equal to C3 by C4, then C5 can be removed. Basically, it simply becomes series parallel. There, these are the three main things. So whenever you solve circuits, right, there are total 5 ways you can solve them: series parallel, Wheatstone bridge, nodal analysis, symmetrical circuits, and Kirchhoff's law. Kirchhoff's law is your final weapon. But maximum, even at mains and bits and advanced may also, the maximum try to solve the questions up to the 4 only. Kirchhoff's law is like brute force. उसमें कुछ इतना interesting नहीं है, मतलब there's nothing much to think, but it will give you the answers. So we will see all the 5 things. Parallel series is easy. Wheatstone, nodal analysis, symmetries. Symmetries is one very important thing. And whatever techniques that you learn in capacitors, exactly same techniques you will use in resistors. Only difference is resistors में series parallel का formulas are reversed, but the techniques we use will be the same. So if you do the circuits properly here, your current electricity meter is taken care of. So let's see how that works. Clear? Let's see our question. No. Capacitor. We have a battery here. Voltage V, C. This is a conducting wire. What does conducting wire do? If you connect 2 points with a wire, what happens?
Potential becomes same.
Potentially.
Bus, potential becomes same. Remember this thing. Other than that, nothing happens. Huh? Potential becomes same. Because of that, something else will happen. Most people think if you connect 2 points, you can remove that. Just remember that thing. If you connect 2 points, potential becomes same. Find C equivalent and charge on each capacitor. Whenever you connect a wire, potential becomes same. Bus. We will see from there. Try. You got a minute.
थ्री सी
कितना है 3C मेरे
So C/6.
3/6 है इतना सा आंसर आ रहा है आपको let's see First thing, there's a statement here, listen carefully. If a conducting wire is connected between 2 points, it makes the potential same. Now, if potential difference across a capacitor becomes 0, not a capacitor, across an element, any element, could be resistor, capacitor, anything, same, it can be removed from the circuit. It is not useful. It can be removed because Q is equal to CV. V is the potential difference. If there's no potential difference, I told you this last time also. See, when you get a shock, you don't get a shock because of voltage. You get a shock because of potential difference. If you're going and touching a live wire, right? Like example, when a crow goes and sits on a live wire, it doesn't die. Reason, both the things have same potential. Potential difference is 0. So in our circuit, what happens to this thing? This can be removed, isn't it? Because these 2 points are connected, that thing becomes useless. You can remove them. All clear with that? Now this capacitor becomes what? C, C, C. All these 3 are in series. This guy, and this guy are in series. That will become how much? C by 3. So battery, and these 2 are in parallel. So this guy will be 2C, and the red one will be C by 3. I'm just coloring them with the same colors. And these 2 are in parallel. So C equivalent will be C1, C2 by C1 plus C2. I'm just using the same formula. I'm reversing it. 1 by C equivalent is 1 by C1 plus 1 by C2. No? You can write C equivalent as C1, C2 by C1 plus C2. This guy will be 2C into C by 3 by 2C plus C by 3. That would be 2C by 7. So the charge which is flowing will be C equivalent into V, 2CV by 7. So from here, charge Q will flow. Remember, whichever plate you touch, that is a positive plate. Automatically, the other plate is negative, which I will not show, plus Q. Then plus Q will go here. It will split Q by 2, Q by 2. So this will be plus Q by 2. Then again, Q comes out, and again, this will become plus Q. And then again, Q comes back to the battery. Remember, battery is like a water cup pump. It is simply pushing water from one place to another. It does not produce charge. So water वापस आना चाहिए वहीं पे. Please check the distribution. To C by 7 it is. Please check the steps. Anyone confused with this? All clear? What if you have a capacitor, capacitor, capacitor? These 2 are joined by wire, and these 2 are joined by wire. This is B, and this is A. Capacitance, capacitance, capacitance. So means battery will be between A and B. Find CAB. Now you can't say I will remove this because this and this point don't have same potential, right? This and this point have same potential. So you can't remove the capacitor. Have a look at this. This looks confusing. Take 30 seconds, then I'll show you a method for this.
Basically, we'll have to redraw the circuit, right?
Yeah. This is where the third method comes, nodal analysis. Now see, I'll tell you, listen, I'll show you one, then I'll ask you more. When you see this kind of question, right, you get a feeling, kuch to connection hai, but you're not understanding what the hell is happening. So we use something called nodal analysis. We have to redraw basically. So in the nodal analysis, what you do, step 1, locate the nodes. And check for nodes with same potential. Step 2, name the nodes. So if 2 nodes have same potential, just put same thing for them. Step 3, redraw the circuit. Now listen carefully here. So in this question, this is point A. So this entire wire is also A. Everyone agrees? If that point is A, the entire wire is also A. If this point is B, this entire wire is also B. How many nodes are there? 1, 2, 3, 4. But how many different nodes are there? Only 2. So A and B, but that's it. There are only 2 nodes. The first capacitor is between what? A and B. Second capacitor is between B and A. Third capacitor is between A and B. हो गया ना? All 3 are in parallel. So C equivalent is 3C. All 3 capacitors are in parallel. Please check how I did this. Step 1, see how many nodes are there. 1, 2, 3, 4. What is a node? Anywhere the branch meets. Step 2, see how many different nodes are there. Since this and this are connected by wire, both should be A. This and this are connected by wire, both should be B. So even though there are 4 nodes, in reality there are only 2 nodes. The first capacitor is between A and B. The second capacitor is between B and A. Third capacitor is between A and B. All 3 are in parallel. Is this clear, everyone? Please check. Ask me if you're confused. Let me give you one more like this. And this you can, this is the method which we'll use. So whenever you see wires, this is the idea. You try for this thing. Capacitor. It doesn't matter, no? Redrawing, what direction will be opposite, Amo? Which direction you're talking? B to A bol rahe ho? Doesn't matter, no? B to A to like this or like this, it is still parallel only, right? This is A, this is B. Capacitance. Get this? Find CAB. ना रे 3C नहीं होगा हर्ष. So generally the hint for using nodal analysis, you will see that conducting wires will be there. So 5C by 3. And now I got 5C by 3. Try. Everyone try. I'll give a minute for each. See the first one, B part. This is connected by wire. This is also A. This is B. This is something else. This is C, na? It is not B. There is a capacitor in middle. That is not B. That is something else. I don't know what it is, but it is something else. How many nodes are there? 3. And remember, generally, whenever you start drawing the nodes, A is the starting point, B is the end point. Agreed? Battery is connected between A and B. Na? Everyone else will be in the middle. So while drawing, make sure that is one thing. Always A and B will be in the corner. Everyone else is in the middle. The first capacitor. For our convenience, I'll just name them. Let's call this capacitor 1, capacitor 2, capacitor 3, capacitor 4. Where is capacitor 1 between? A and
A
C.
and C.
Capacitor 2 between?
A and C.
A and C. Capacitor 3 between?
A and B.
A and B. Capacitor 4 between?
B and C.
Do you know how to solve this? हो गया ना? Parallel, series, parallel. So this can be simply drawn as 2C, C, C. 2C, C will become 2C by 3, C. Both are in parallel, so C equivalent will be 5C by 3. Please check. The circuit simply ends off to be series and parallel anyway. Please check, ask me if you're confused.
Sir, can you explain B again?
Which part?
Sir,
Which part you
like
didn't understand? ACB understood?
so I'm confused in the first step. Like, how did you name those noodles? I got four nodes.
4
How
are
are
there,
you
na?
getting?
But these two you're connecting with a wire, na? If you connect something with a wire, what will happen
Yes.
to the potential? If you connect 2 points with a wire, what happens to the potential?
It will stay the same.
Same. So that means if this is A, this is also A only, na?
Yes, sir. But then I'm confused, like the B and C part.
Now B is this. Are B and C connected with a wire?
Acha, okay.
No, it
Okay,
should be
okay.
something else, na? See, if there is a wire, they're equal. If there is no wire, I don't know what it is. It is something else. Huh, Vrinda? So
Yes, sir.
if they are connected by wire, they're equal. If they're not connected by wire, if there is a capacitor or a battery in middle, then there will be definitely different points. Got it? So that's why I called it point C. Sure. Others, please ask
Yes.
me if you can. It's this thing. If you got this, chalo, do the C part. Question is there. Try C. This is how they'll play around series parallel. That's why I said these circuits are like kind of interesting. And the same ideas we'll use in resistors also. How do we do this? 9c by 8. Again, see. Remember, only if you connect with the wire, you are same, okay? So this is A. Since you're connecting with the wire, this entire wire is A. So this guy is also A. Agreed?
Sir, can you wait for 2 minutes?
Karo. That entire wire is A. That much I know. Nine C by 8. Let's see. So if that is A, that is also A. This is B. Agreed? What is this guy? Some C, no? It is not connected to anyone. It is C. What is this guy? Some D, no? Simple. If whenever you go from one place to another and beach mein capacitor hai, the potential will change. Simple. Keep that simple thing. Like, whenever you go from here, there is a capacitor in the middle. The potential should change. Everyone agrees to the points. There are 4 points. A is the starting point. B is the end point. C and D. Now you might get a doubt, sir, how to know which one to take C, which one to C to D? Simple thing. Think like this. When you're traveling from A to B, which point comes first? C, na? The battery is connected between A and B. So when the charge is going from A to B, how it goes? ACDB, right? So go in that order only. So put the points also in the same order. Let's name the capacitors for our convenience. Capacitor 1, capacitor 2, 3, 4, 5, 6, 7. Capacitor 1 is between A and C. Capacitor 2 is also between A and C. Capacitor 3 is between C and D. Capacitor 4 is between A and D. Capacitor 5 is between D and B. Capacitor 6 and 7 are between A and B. Can't you solve this? सब series parallel में है. These two are in parallel. This whole thing is in series. That and this are in parallel. This whole thing is in series. This and this are in parallel. Series parallel, series parallel, series parallel ऐसा हो जाएगा. So how much will this be? CC 2C, 2CC, 2C by 3, 5C by 3, 5C by 3 plus 5C by 3 plus C. That would be 5C by 8, 5C by 8 and C by 2. So 5C. And C by 8, and this is 5C by 8 and C by 2. So 8 will cancel. 5c by 18 आ रहा है ना आंसर? What is the answer? Anyone else got that? 9c by 8 आया क्या? I cooked up क्या? Let me see again. This is 2c. 2c and c is 2c by 3. 2c by 3 plus c is 5c by 3. 5c by 3 c is 5c by 3 into 3. 5c by 3 plus c. That is 5c by 8. 5c by 8 and this is c by 2. दोनों parallel में है ना? I have to add. So be careful, right? See, even I'm cooking up 9c by 8. वो है series parallel का 9c by 8 is equivalent. Please check how to do this thing. Let's see one more like this.
But how did you
Okay.
get 9c by 8?
After solving. solve. Series parallel आ रहे सबका वही आ रहा है आंसर. Solve करो, I will leave it to you. I'll just try to help you see. ये पूरा branch का ना,
That is 2c by 3.
that is 2c by 3.
And
That
उसमें
and this
नीचे का
branch
parallel
5c
add किया
by
तो
3.
5c by 3.
That and this thing will be 5c by 8. वो और नीचे c by 2 से ऐड होगा.
Okay, हाँ. Instead of taking 5c by 8, I took 8c by 3. No problem.
होता है वो. Let's say we have parallel plates like this. Batteries between these 2 points. So there are 6 parallel plates. Area A, distance between them is D. Find C equivalent. Plate 1 and 5 are connected by a wire. Battery is between 3 and 6. This and the previous one are logic same tha. Just that I gave parallel plates here. Previously I gave you capacitors. How many capacitors are there here? How many are there?
5.
7.
Remember what is a capacitor? Capacitor is a
7.
space between them.
Space
1,
between.
2, 3, 4, 5.
Sir, but from that to R to infinity.
हाँ, R to infinity. Parallel plates में.
अच्छा हाँ ठीक है वो तो spherical में था ठीक.
Spherical का होता है. Parallel plate का नहीं होता है.
Okay.
Parallel plate में there are n plates. You get n minus 1 capacitors.
Okay.
Get this? Infinities don't consider a parallel plates, people. Only spherical capacitor में infinity count होगा. Parallel plates में count नहीं होगा. Get this. So there are 5 capacitors here. Try. I'll give you a minute or two. E answers. How do you start? Step 1. See how many different plates are there here. So let's name the plates. This is the point now. Let's call this A. Let's call this B. Agreed? If I call this C, and if I call this D, this has to be D and this has to be E. Agreed? There are total how many? 5 different plates. So start the points here. A, B will be in the corner. Yeah, be little careful here. This might crisscross actually. A say you're going then to C, then you have a D, and then you have a E. ठीक है? I went like this directly first. A C D B. बीच में E होगा. So let's the first capacitor. Let's call this guy C1, C2, C3, C4, C5. In reality, all are same actually. C1, C2, C3, C4, C5 is nothing but A epsilon by D. So first capacitor C1 is between what? D and D. Second capacitor C2 is between A and E. Third capacitor is between A and C. Fourth capacitor is between C and D. Fifth capacitor is between B and D. थोड़ा twist हो गया. So you can rearrange this also actually. So you can keep E and D reverse actually. So C1 is between D and D. C2 is between A and C. C2 is between A and E. C3 is between A and C. C4 is between C and D. C5 is between B and D. There. So C3 and C4 are in series, and this is in series. Clear? It got a little twisted here and there, but I think you can clearly see series, everything here. The whole circuit looks like this. That was easy to solve, no? If you draw it like this. Clear? Any doubts, please ask. Brinda, clear with this? Let me show you one more like this. So let's say battery is connected between these 2 points. And now find the capacitance. One and 4 and 2 and 5 are connected by wires. Batteries between 1 and 2 plates. If this is A, isn't this also A? If that is B, this is also B. That means this plate is some C, na? So there are actually only 3 points, A, C, B. The first capacitor is between A and B. Second capacitor is between B and C. Third capacitor is between C and A. And the fourth capacitor is again between A and B. Is that making sense? Check. By C by 2. Clear? I hope this connecting wire ka thing you're getting it. Any doubts on this? Turning the page. Do ask me if you're confused here. Any step that you're not clear. So there is a switch here. Two C, 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 and 2C. This is a battery. Find C equivalent before and after closing the switch. How much charge flows through the battery? When switch is closed. C part, I'll leave it as a homework for you. How much charge flows through the switch when the switch is closed? Let's get A and B part first. Try this. Okay. Think. So when you open the switch, the circuit is like this. This is easy, right? So 2C, 2C, this will be 2C by 3, 2C by 3, 4C by 3. And how much charge went through the battery? 4 CV by 3. After closing the switch, you will notice this. It has actually become like this. The 2C and C now both become parallel. You can just redraw like this, isn't it? You can make this wire like a, you can close this and make it a point. Make sense? Suddenly the 2C and the niche ka C become parallel. So we get C equivalent will be, this is 3C, 3C, that will be 3C by 2. So how much charge flows now? 3 CV by 2. So how much extra charge flowed here? The difference. So charge to the battery will be the difference in charge flow. Finally, 3 CV by 2 flowed. Initially, 4 CV by 3. So the difference must have flowed. 3 3s are 9, 9 minus 8. So CV by 6. Check. Right, Kavish, you got that right. Yeah, most of you got it. Harsh, Ammu, Shaurya, Anamai. Please check. That's the difference before and after closing the switch. Huh, Vrinda? Trisha? Got this? Arushi? Asni? Yeah, Ritam, Prerna? Chirayu? Nishita? Got this? Gauri? Clear? Aviksha? Got this?
So could you explain the after case once? How did you change the one?
Which one?
After
ये
this?
ये दोनों सेम हो गया ना रिकॉर्ड अम्मू, तो इसको एक वायर बना सकता हो ना, पॉइंट बन गया ये
Okay.
ना. So I just folded them, so I can just stretch the wire and fold it na middle में, that entire wire become point. Next one. Now all are C capacitance. P by 2. I think so. See, this is actually a hidden Wheatstone bridge. This point is C, this point is D. There is not a different point. All points are different. Agreed? There's not a single common thing here. All 4 points are different. So whenever you get like this, so there is nothing in common. So A, C, if I draw like this, you can clearly see like this thing. Because see, you're going from A to C, you're going from A to D. Both are equidistant. Look at the capacitor. You have a capacitor between A and C. You have a capacitor between C and D. You have a capacitor between B and D. You have a capacitor between these two guys. And you have a capacitor between these two. Okay. It's a Wheatstone bridge, right? So basically this capacitor can be removed. The one between C and D, na, this guy is gone. So this circuit simply becomes capacitor, 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 and done. That will be C, this will be C. Check. It's a hidden Wheatstone bridge. Thoda twist karna tha. You can actually clearly see here, see. If you take this point and stretch it here, this point here, you can see it's a Wheatstone bridge. Isn't it? Circuit, if you just bend it a little, you can see there's a Wheatstone bridge. All clear with this? How, Vrinda?
The previous question that he gave us, say if the ratio was same, right?
This one?
So then, yes, if the ratio was same, then that would have also been similar to
But this
Wheatstone.
is not a capacitor, na? But if the ratio was same, so it would have been same. Doesn't matter. Let's say this is 2cc and this is cc. Even if you put a wire, it won't make a difference. The answer will remain same.
Sir.
But this thing, the ratio doesn't match actually. This is 2:half.
That's what I'm saying. If the ratio
Yeah,
was
yeah.
same.
You could have just removed that wire in the middle. It won't matter. All clear with this? Let me show you one more hidden Wheatstone bridge. I shouldn't be telling you that actually. The wire jumped across it. It is not touching it. This is the end. All RC. The wire in the middle, they're not touching each other. It is going over it. Try. Or C. Let's call this point C. Let's call this point D. There are 4 points here: A, C, D, and B. Between A and C, there is one capacitor. Between C and D, there is one capacitor. Between D and B, there is one capacitor. Between A and D, there is one capacitor. One capacitor, and between A and B, there is one capacitor. This is a Wheatstone bridge in parallel to a capacitor. So basically, this guy is this guy. You can remove this one. Check. So this simply becomes that is C and C. So C equivalent is 2C. So this is a Wheatstone bridge which is parallel to one more capacitor. Do have a look at this, everyone. Clear? Next one. We have a capacitor, 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 capacitor. So until infinity. C, C, all are equivalent. Find the capacitance between A and B.
सर जीपी बनेगा क्या?
कर लो. Get me the answer. You can make whatever you want. Right. Standard question. This is a standard one, 15A. I'll give you a little different variation of this. So now we entered into symmetries. So till now we have done series parallel, Wheatstone bridge, nodal analysis. This is the fourth type. Now symmetries, there are a lot of varieties. Infinite symmetries, axial symmetry, bisector symmetry, diagonal symmetry, cube symmetry, infinite grids. So we will be seeing that today and tomorrow. Symmetries are the most important ones. So this is the first type, infinite symmetries. And this is a standard question. This is a question you can expect directly in mains and bits. Bits are directly you can definitely expect. Mains was not like 5-6 years back. Things have changed a lot in mains. They are literally repeating questions, and they're asking pretty dumb ones. Advanced में फिर भी they're still slaughtering people. I think this year we got 1200, 13, 14. All three are taking IIT Bombay mechanical. किसी को बॉम्बे छोड़ के जाना ही नहीं है. They're coming July 9th. को. You guys can meet them, talk to them. I call your juniors also 11th standard. You can rank them. Shaurya को छोड़ देंगे juniors पे attack. हाँ रे Shaurya, when they come na, we will introduce you like that only. This is Shaurya, right? He is my 2017 batch का student. He got into IIT Bombay करके ऐसा कुछ fake करेंगे. You tell them that only. You guys have to put every day at least 20-22 hours study नहीं करेंगे तो very difficult. You scare them off. They'll ask you, sir, Abhi, what are you doing? You tell them, I'm planning to join ISIS. Yeah, IIT Bombay this year say they stopped the branch change. How to do this 2C नहीं रे इतना beautiful answer आएगा नंदा.
Oh, 1 plus root 17 by 2r.
Root 17 नहीं आएगा. God, you must have the calculation somewhere. See, the idea here is when you get an infinite branch of this sort, if you cut it here, isn't it still infinity? If you cut it here, it's still infinity. So let C A B equal to X. So let the whole answer be X. That means if you cut it here, and if you replace that whole infinite branch with this, shouldn't this be X only? So this is C and this is C. So if I take the equivalent of this, what is that again? Isn't that X again? The equivalent of whole thing is what? Isn't that X? The
Sir.
idea for this question, right? हाँ Shravya.
सर ऐसा ये इनफाइनाइट पुली वाला प्रॉब्लम था वैसा ही किया ना हमने.
Actually ये question ना, this concept is taken from Max. Do you guys remember this concept?
अंडर रूट टू वाला ना.
ऐसा question याद है? So this will be nothing but y is equal to root over x plus y, na? Done anything like this in Max? So it was the inspiration from that thing, infinite grid. So you're done actually. Abhi C and X कितना होगा equivalent इसका? C and X will be C plus X. C plus X and C are in parallel. So C plus X plus C. This should be equal to again X. That will be C square plus CX. 2CX plus X square. X square plus Cx minus C square is 0. X is equal to minus C plus root over B square 4AC by 2. Root 5 minus 1 by 2C. Check, that's your answer. हाँ कभी 17 कैसा आया?
और किधर ना किधर 4 आ गए.
The main idea in these kind of questions is that you can replace that whole thing. If you leave one branch and replace it, it will still be X only. And the equivalent is again an X. And inspiration for that problem is that y is root over X plus X, that thing. And based on this, if you remember, I know most of you are not there in that time. We did a problem in NLM, an infinite pulley problem. We had a pulley going on till infinity. So we actually replaced all that pulleys with one single pulley and we got an equivalent pulley. So this problem was actually inspired by the resistance ka problem. Resistance was inspired by the Max ka problem. Do have a look at this. Now what I wanted to do, tomorrow you try and come. B, suppose same thing. Capacitance. So until let's put one more branch, capacitance. And so on till infinity. C, this is KC, this is K square C, this is K square C, and so on. K is a constant. So the capacitance for each branch is increasing by a factor of K. Find CAB. Try this. So tomorrow when we meet, 9 o'clock tomorrow we'll have a class. We'll meet, continue from here. You ना शौर्या GP के पीछे
इधर वो जीपी का कॉन्सेप्ट आएगा ना.
GP नहीं आएगा रे भाई बिहाइंड GP है शौर्य. इसमें कहाँ पे GP दिखा रहे थे इन्फिनिट ग्रिड में.
सर के से इंक्रीज होता रहेगा तो मुझे लगा इनफाइनाइट जी.
तो मतलब भाई आई थिंक व्हेन यू कम ना वी विल से यू आर अ जूनियर करके तुझे रैगिंग करेंगे. तो Try karo. Yes, tomorrow we'll discuss the thing. Did I tell you, like, how we not exactly ragging nahi bolte abhi. People will feel offended, but what we did, But all got this concept clear, hai na?